Bismillahirrahmanirrahim. My name is Roshad Imran Birosli, Mathematics at the NA1 Examinations. My group mate will present about the series and parallel pump. Okay, this is my group mate. Okay, for the first one, the introduction. Figure 1 shows about the series pump curve, while the second one shows the parallel pump curve. Okay, first of all, pumps are frequently used as equipment to help liquids move or flow. According to it, there are numerous types and size of pump. Okay, the first configuration is a sequence of operation in which one pump discharges directly into the suction of the second pump. Both pumps delivering the same flow rate but working together to create a single pressure, while the second configuration is parallel operation in which two or more pumps share the flow at the same altitude by drawing from one common header and discharging to another common header. Okay. So figure 1 demonstrates how using multiple pump in series can prevent a greater system head loss than using a single pump alone, while the head move along the flow rate system curve from the point 1 to point 2. Point 3 tends to move along the constant flow rate combined line from point 1 to point 2. Okay. So the objective is to demonstrate the pump of one curve for single pump configuration, series pump, and parallel pump. The problem statement of this experiment is when multiple pumps must run simultaneously on the same system, this presents one of the difficulties that users of the pump regularly encounter. There are two setups with such numerous pump systems where the operational property of the varies. It is possible to think about pump as having a single combined performance curve. The first configuration is referred to as series operation in which pump discharges directly into the second pump suction, while both pumps are operating at the same flow rate and contributing to the creation of the combined pressure. The second configuration is known as parallel operation, in which two or more pumps operate at the same head while sharing the flow by sucking into one common header and discharging into another. So the aim of this simulation is to familiarize participants with the behavior of connected pump system in series and parallel, as well as the fluid flow through connected pipe system series and parallel. Additionally, we wish to become more acquainted with the idea of the pump curve.
Assalamualaikum and hi. My name is Muhammad Azami bin Zahari. ID number MA19076. I will continue for the theory. First, let's take a look for pump efficiency. Pump efficiency is a critical performance aspect in series or parallel pump designs. The specific efficiencies of each pump in the system greatly affect the overall efficiency. Various factors impact the effectiveness of each pump, including impeller design, fluid viscosity and density, and operating condition, speed and head. Choosing pumps with high efficiency is crucial to reduce energy losses and increase the overall system efficiency. For the system resistance, series and parallel pumps operate differently based on the resistance imposed by the system's pipes, fittings, valves, and hydraulic components. The total head required to overcome systems resistance is influenced by friction losses due to fluid flow through pipes, elevation change, and pressure drops across fittings. Proper design and sizing of components and accurate estimation of system resistance are crucial for optimal system performance. Minimizing losses can enhance system performance by selecting the appropriate pipe size, reducing bends and fittings, and optimizing the arrangement of pipes. Next is flow distribution. Equal flow distribution among pumps in a parallel pump system is crucial for the effective operation. Uneven loading of pump due to unequal flow distribution can lead to issues such as excessive wear, reduces efficiency, and premature pump failure. Flow distribution can be influenced by factors such as pump characteristics, pipe length, and system resistance. Proper flow balancing procedures and control system, such as flow control valve or variable speed drive, can be implemented to achieve even flow distribution among parallel pumps. Flow meters and pressure sensors may be used to monitor and regulate flow rates, ensuring optimum performance and reliability. Thank you.
Assalamualaikum, my name is Muhammad Azam bin Zahari. Next, I will continue with methodology. First, I will tell you about experimental setup. Here we have water tank, manometers, centrifugal pump, manual valve, and hydraulic power input. Here we have three types of pump operation. First, we have single pump operation. For procedure, first, the selection valve is set to single pump configuration. Second, the single pump is turned on by turning the switch to the left. Third, the volumetric flow is adjusted using the output volume. P-suction, P-delivery, and volumetric flow rate are recorded. And last, step 2 to 4 are repeated with different volumetric flow rates. For a series pump operation, first, to turn on both pumps, move the switch to the right. The output of amount is used to change the volumetric flow. The P-suction, P-delivery, and flow rate are all written down. The last one, steps 2 to 4 are done again, but this time with different flow rate. The last one is parallel pump operation. First, the selection valve is set to the parallel pump setup. Second, to turn on both pump, move the switch to the right. Third, the output amount is used to change the volumetric flow. The P-suction and P-delivery and flow rate are all written down. Last one, step 2 to 4 are done again, but this time is different flow rate. That's all from me, thank you.
Hi, my name is Intan Fazana, MA18138. Now I will continue with the results. So for the graph, this is the single pump configuration graph from the graph of head against the flow rate. This is the series pump configuration, the graph of head against the flow rate, and also this is a parallel pump configuration graph, head against flow rate. So for the calculation, so if we need to find the net head for single pump configuration, which is H1 equal to rho delivery over rho times gravity, and so on. And for the series pump configuration, we need to find the rho delivery for pump 1 plus rho delivery pump 2 over rho times gravity. And for parallel pump configuration, we take the pump 1, which is same as the single pump configuration, and we take the pump 2, also the same, and we take the total to find H1. To find the water horsepower, so this is the result from a single pump configuration. So I take this as an example. So for single pump configuration, we find the water horsepower, which is rho times gravity times Q, also times H, which is we got 1000 times 9.81, 0.004155 times 25.96, which is we got 105.81 watt, which is same as this one. Okay, that's all for me. I pass to the next presenter. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Swan Siti Fairuz binti Wan Muhammad Azmi, and my ID number is MA19038. So I'm going to present about the discussion of this experiment. So the first one is compare the experiment performance curve to its theoretical curve and describe the discrepancy factor. So for the parallel pump, it has the highest head but has the lowest flow rate. Single pump and parallel pump performance curve almost like the theoretical pump performance curve. As a result of the experiment, the parallel pump has the greatest flow capacity. Second, from the result obtained, state the use of the series and also parallel pump. So, the use of a series pump is to increase the capacity of the total head without change its water flow rate. So for the parallel pump, it increases the flow rate but it maintains the capacity of the total head. Next is about why the system with series pump configuration would generate higher pressure than the parallel pump configuration. It is because the system with series pump configuration would generate higher pressure than the parallel pump configuration because it takes more power to overcome the high load in a series pump setup. The pumps arranged in series are also able to meet high head requirements by the summation of the heads. I think that's all from me. Thank you.
The conclusion of the experiment is that we discover that pumps generate in different ways while in series and parallel. Reviewing the data reveals that multiple small pumps connected in order require less horsepower than a single huge pump that is meeting at a single spot. In addition, parallel couple pumps can achieve a larger flow rate. It has been seen that each type of pump exhibits behavior that can be explained by either a series connection or parallel connection. A series connection causes the pump to transport fluid to the expected height, but a parallel connection causes the pump's flow rate to increase the excessively. That's all from us. Thank you.